A permutation trick, number 16. Permutation we haven't talked too much about. I might have mentioned it before, but permutation comes up when we're talking about the order of objects or things or letters or numbers. And when you have a combination, it means that order doesn't matter. So if I ask you what numbers came up on a pair of dice when you rolled them, you could say a 6 and a 2, but you could also say a 2 and a 6. The order that you say them doesn't matter. Just like my fruit salad has grapes, bananas, and mangoes, it doesn't matter if I say my fruit salad has bananas, grapes, and mangoes. This order does not matter. Permutation, order does matter. For example, my telephone number is 697-5934. So the order of these digits is what makes my phone ring when somebody keys those in. So combinations, there's things that are put together. Order doesn't matter. Permutation, order does matter. Again, the way I remember this is permutation is a weird word. We're probably not as familiar with it. And so that's the one where it's more important. For me, that makes sense. Don't think about a lock combination with this. That'll get you into trouble because a lock combination order does matter. Okay, so why does this trick work? This trick works, of course, because of algebra. And again, instead of using numbers, we're going to use letters. So we're going to call the letters X and Y because you were able to put on a card an X or a single digit, and on the third card you put a decimal point. So I'm going to use an X, I'm going to use a Y, and here's my decimal point. So they want to know how many different orders, this is a permutation, these can go in. So when you were doing it with numbers, if you chose 3 and 1 and the decimal point, the way I would do this is I would say 3, 1 decimal point, and then 1, 3 decimal point. And that would be 2 of the ways I could arrange these, having the decimal point appear after the ones place. Then I'm going to leave that decimal point right there, but I'm going to move and shift my 3 and my 1 so that they appear on either side of it. And then again, I'm going to leave my decimal point there, but I'm going to write my 2 digits to the right of the decimal point. So we want to represent that over here with our X and our Y and our decimal point. So we have XY decimal point, YX, X decimal point Y, Y decimal point X, decimal point XY, and then YX decimal point. At this point in the trick over here, the person that you're doing the trick with is asked to sum these digits. So they're going to add all of them up. This number, by the way, is a palindrome. A palindrome means it reads the same forward and backward. There are words that are palindromes, like mom, Bob. They read the same forward and backward, but numbers are also palindromes. So you'll notice over here, when I'm looking at this, I see that I have an X and a Y. So this is a little more difficult to sum. And I am going to sum it. The good news is I don't have to carry anything. So I'm going to look at this in terms of this being the tens place, and this being the ones place, and this being the 1/10ths place, and this being the 100ths place. So if I were to draw my place columns, it would look like that. So right here I have x plus y, and I would need to multiply that sum by 100th because they are in the 100ths place. Over here, when I look right here, I added the 3 plus the 1, and it's in the hundredths place right there. So because these are variables, I'm going to write these down as a sum, and then I'm going to multiply it by the 100th place. So x plus y, and then I'm going to multiply that times 100th. So I'm done with that column. Right here, I'm going to be multiplying by 1/10, but you'll notice I have two x's, excuse me, and I have two y's, but I'm going to multiply that by 1/10. So I have two x's and two y's, and I'm going to be multiplying that by 1/10. Over here in the ones column, I have 2 y's and 2 x's. And I'm going to be multiplying that by 1. And in the tens column, I have 1 x and I have 1 y. And I'm going to be multiplying that by 10. So this expression right here represents the sum that I would get when I add these up. So I'm just going to write this down here because this right-hand side is with the example and this left-hand side is with the variables. So I'm at this point. I just took the sum of the numbers that I created. Now what I'm going to do next is I'm going to show you what happens when we start manipulating and using math skills in here on the left-hand side. I'm not going to do it on the right-hand side until we get down to the directions where you start telling the person to multiply by 100. So when I look at this, I notice that in every single term, and remember my terms are separated by my plus or my minus signs. So I have 1 term, 2 terms, 3 terms, 4 terms. In every single term, I have an x and a y. So what I'm going to do is I'm going to factor out the x and y of every term. Now this one, I just have an x and a y. So I'm just simply going to rewrite this term, but instead of putting the 10 at the end, well, I can just leave it at the end. So I have x plus y times 10 plus, now you'll notice here I have an x and I have a y, but I'm going to factor out these 2's. So I have 2 times x plus y times 1, this 1 at the end. Now I have the same thing right here. I have a 2 I can factor out. 2 times x plus y, but I also have to multiply, remember, by 1/10. And down here I just have x and y and times 100th. Now just because I'm Mrs. Porish. I don't like to deal with fractions as well as I like to deal with decimals. So I'm going to do a little bit of rewriting here, and I'm also going to note when I get to this term and this term, I'm going to rearrange my multiplication problem. Now with this one, again, it just stays x plus y times 10 plus, now this I'm going to take this factor, because this is just a factor, times a factor, times a factor. So I'm going to take my 2, and I'm going to multiply it by my 1, and I'm going to take all of that times x plus y. And then when I get to my next term, I'm going to do the same thing. I'm going to take my 2, and I'm going to multiply it by my 1/10, except I'm going to represent that as this. And then I'm going to multiply that times x plus y. And then I'm going to change this into 1/100th and multiply times x plus y. Now, when I go back, I know this is a lot of steps, but I want to make sure I don't miss anything. 2 times 1 is simply 2 times x plus y plus 2 times 1/10 is 0 and 2/10 times x plus y. Plus, and here I didn't multiply my 1/100th times anything. Okay, so now when I examine this, I can see that in every single term I have an x plus y. So now I can factor out my x plus y. I'm going to factor out my x plus y, and what I'm going to do is I'm just going to then take my other quantities, and inside parentheses I'm going to add them together. 10 plus 2 plus 2/10 plus 1/100th. Now I'm going to simplify that. Adjust my camera. And I'm going to add 10 plus 2 and get 12. And again, I'm being pretty methodical here. Plus 20/100ths times x plus y. And then what I get here is x plus y times 12 and 20/100ths. So this is the math for what happens when you make the variables x plus y and you add them. This is simply showing me what happens when I add all of this together. This mathematically is what I end up with in this particular situation. So when I look at my big problem again, I still am right there. I've just added everything together. So in the directions now, the next direction is to start multiplying things. So in the instructions, you are to take this number and you are to multiply it by 100. And if I did that with this number, I would get 4,000 884. So over here, when I multiply by 100, I am going to get x plus y, which is one factor, times 12 and 21/100ths, which is another factor, times 100. So I'm simply going to multiply these two things together, and I'm going to get x plus y times 1,221. Now what I'm going to do next, it says take that answer that you get and divide by 11. So here's my answer I got, divided by 11. And when I do that with my calculator, I get oh, I keyed it in wrong. $444. So now I'm going to take this quantity, x plus y times 221 or 1,221, and I'm going to divide by 11. And when I do that, I'm going to get 1,221 divided by 11 equals 111. So that's going to be x plus y times 111. So this answer is correlating to this answer. Now I have to divide by 3. So I'm going to take this answer and divide by 3. By the way, if you can sum these digits and get a number that's divisible by 3, 4 plus 4 plus 4 is 12. 12 is divisible by 3. The whole number is divisible by 3. And I get, glare, 148. So I'm going to take x plus y. I'm running out of room. X plus y and I'm going to divide this by 3. Now remember, when I add these together I get 3, so 111 is going to be divisible by 3. So clear, I get 37. So when I take 148 divided by 3, and again if I add these together, oh wait, that's what I got when I divided by 8, sorry, or divided by 3. I got 148. So now after you have done that, you divide this result by the sum of the two digits that were first selected. So this result divided by the sum of the two digits that was first selected. So the sum of 3 plus 1 is 4. So I'm going to divide this by 4. And that equals 37. So because 37 times the sum of the digits is going to give you this answer. Remember that division and multiplication are opposites. They're inverses. So I could take 37 right here and right here, the sum of my digits, here's the sum of my digits, and I would get that answer. So that mathematically is why this trick works.